Hello. In this lesson I would like to calculate some derivatives that you may find useful. Not so much that you need to memorize the results of these derivatives for these functions, but rather I'd like to show you a way to calculate derivatives of functions that can be expressed in regards to already known functions. So as you know, the functions tangent, cotangent, secant and cosecant can be expressed very easily in regards to sine and cosine. One other thing that I like to mention right from the start is that all those rules for differentiation that you know from the polynomial functions that we studied in the second chapter, they continue to apply for trigonometric functions as well. Therefore, constant multiple, sum, difference, the power rule, the product rule, the chain rule, and the quotient rule, they all apply to trigonometric functions as well. In this lesson I'm going to show you how you can calculate the derivatives of these four functions just using the rules that are already known to us and see what kind of results we can find. Let's start by considering the function tangent of x. If y is tangent of x, then the derivative dy dx is going to be the derivative of, and I'm going to express tangent of x in regards to sine and cosine. So it's going to be d dx of sine of x over cosine of x. It's a quotient, so I'm going to apply the quotient rule. It's going to be equal to derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, everything over the denominator at power 2. I'm going to replace that derivatives with their values, so it's going to be cosine of x times the cosine of x which was already there minus sine of x times derivative of cosine of x we know is equal minus sine of x, everything divided by cosine square of x. Let's simplify this expression further. That first product is going to result into cosine square of x plus sine square of x, everything divided by cosine square of x. According to the fundamental identity of trigonometry, cosine square of x plus sine square of x is equal to 1. This expression is going to be equal to 1 over cosine square of x. And as we know, 1 over cosine of x, it's a reciprocal function, and because it was square, it's secant square of x. So this is what derivative of tangent of x equals to. Let's go further and calculate the derivative of a cotangent. Considering y to be cotangent of x, the derivative dy dx is going to be derivative d dx of cosine of x over sine of x. We have a quotient once again, so we're going to apply the quotient rule. d dx of cosine of x times sine of x minus cosine of x times d dx of sine of x, everything divided by sine square of x. Let's replace those derivatives. Derivative of cosine of x is going to be negative sine of x times sine of x minus cosine of x times derivative of sine of x is cosine of x, everything over sine square of x. Simplify this expression to minus sine square of x minus cosine square of x, everything over sine square of x. This negative sign I can put it in front of the fraction line, and in the numerator we're gonna keep sine square of x plus cosine square of x, everything over sine square of x. Applying the fundamental identity of trigonometry once again is going to be minus. In the numerator it becomes 1, and denominator sine square of x, which we recognize it's the reciprocal function cosecant. So we can continue to say even that is equal to negative cosecant square of x. Now let's calculate the derivatives of the reciprocal functions and start with cosecant of x. Cosecant is 1 over sine of x, so its derivative we're going to calculate d dx of 1 over sine of x. It's a quotient, it's actually a simple quotient, but we could calculate this as a power, but I'm going to use just the same quotient rule. So you're going to have d dx of 1 times sine of x minus 1 times d dx of sine of x over sine square of x. What is the derivative of a constant? we know that is 0. So the first term is going to be 0 times anything is going to be 0. I'm not going to write that anymore. And the second term is going to be minus that 1. I don't have to write it. And ddx of sine of x is cosine of x. So it's minus cosine of x over sine square of x. I can express this maybe a little nicer by writing just like that. Minus cosine of x over sine of x times 1 over sine of x, which we recognize is minus cotangent of x times cosecant of x. You can have either of these final forms, whichever you prefer most. And finally, let's calculate the derivative of the reciprocal function. So when y equals secant of x, then dy dx is going to be express this in regards to cosine of x. So it's d dx of 1 over cosine of x, because this is secant of x. And applying the same quotient rule, I'm going to have d dx of 1 times cosine of x minus 1 times d dx of cosine of x, everything divided by cosine square of x. d dx of 1 is a constant, so it's going to be 0. So I'm not going to write anymore that term. The next that follows is minus, and d dx of cosine of x is minus sine of x. I'm going to put it in parentheses. Everything over cosine square of x. Those two negative signs multiplied together are going to become positive. So it's sine over cosine square. I'm going to write it as a product of cosine and times cosine. So the derivative is going to be tangent of x times secant of x. So to conclude this lesson, let's actually review the results that we found for all 4 functions. We're going to say that the derivative of tangent of x is secant square of x. Derivative of cotangent of x is minus cosecant square of x. The derivative of cosecant of x is going to be minus cotangent of x times cosecant of x. And the derivative of secant of x is going to be tangent of x times secant of x. And with this, we conclude our lesson. Thanks for watching.